Electromagnetic induction is now firmly established in our lives. Almost every person on the planet takes advantage of it on a daily basis, but far fewer people know how it works. These podcasts will hopefully remedy this. Electromagnetic induction is a process of using properties of magnetic fields to move electrons to form electrical currents. You can use a bar magnet to pick up paper clips. Paper clips are not very heavy. In order to lift objects in a range of tons rather than grams, you need to use coils of wire with current passing through them to make electromagnets. This is the first half of electromagnetic induction. A moving charge makes a magnetic field. If you concentrate these magnetic fields so that they overlap, you can generate much greater magnetic fields. You do this by forcing the charges into line and down a wire into a current. You can then further concentrate this magnetic field by bending the wire into a loop. You can further increase this magnetic field by adding even more loops. You can make the magnetic field even stronger by changing the material that holds the magnetic field. You change the core to change the permeability of the area the magnetic field is in, which will increase the field strength. Passing a wire through a fixed magnetic field is the second aspect of electromagnetic induction. Instead of making an object move by placing it near the coil of wire generating a magnetic field, you now place a wire through a stationary magnetic field. The motion makes the wire cut through magnetic field lines, or lines of flux, and causes the electrons in the wire to all move in the same direction at the same time. The electrons orbiting the atoms inside the wire have a negative charge. Moving the whole wire makes the charged electrons move in a magnetic field. This in turn makes electrons move following Fleming's left-hand rule, generating a current in the wire. The same rules as previously applies here. If you want to make a bigger current, you need to make the charge move faster and therefore generate a bigger force. Force on the charge is directly proportional to the magnetic flux density times the size of the charge times the speed the charge is moving. The charge size doesn't change. You can increase the strength of the field, but not very easily. So instead, you make the wire move faster. This makes the charged particles move faster and generates a bigger current.